Programming patterns are your happy little friends. The sweet and tiny things in the world of responsible programming can be called strong and common solution patterns. And what is even cooler is that you already know them all just by poking at various programs and web pages. The uncommon patterns are rare because they are unstable or can't translate well between the world of mobile and desktop development. Now, the uncommon patterns are great entertainment for when you are learning or try to invent something new. But if they end up in your program on launch day, you will discover that you will somewhat regret using them at launch. Launching a product is a very delicate process, and there is a great deal of confidence in common, standard, out-of-the-box solution patterns. To give a rather terrible example, use a plain drop-down box for when the user needs to select from a set of options. You don't need a fruity Fruit Loop fruitcake interface with transitions and shadows. Because the one thing that you can be certain of is that a notable percent of your users will be using fruity computers, old and somewhat rusty Raspberry Pis. And, every once in a while, you get a once proud ATM machine that was stolen somehow. And there's always that goddamned electrolyte-powered potato computer. This happens all the time. And of course, a fleshy, fat butt-dialing butt that yearns for a box of Fifi, despite the constant negative press. Aside from being common and reliable, all the solution patterns that you are familiar with are powerful. After all, you are seeing just the end user interface. There is almost always a very good programming reason right beneath, and you don't need to be a programmer to figure it out. One of my favorite programming patterns is a record browser, because records in a database table always have a set number of well-defined fields. That is a constraint that comes from relational databases, which themselves are a pattern worth mentioning. The database just uses 3 simple functions: union, difference, and intersection, along with lesser stuff like chunk, filter, and map. When performing operations on 2 tables of data, where every row is a record or user account or email message or item in a cart, and the columns are just labels for things like username, from, to, subject, or price, or date of purchase, you will need a stable set of well-defined fields. So if you are going to make a list of logged-in users that have stuff in their shopping carts, you will perform an intersection on username field in logged-in table and username field in shopping cart table. An intersection creates a list of unique values that are included in both tables. So, logged in with stuff in the shopping cart. So now look at what you can make. You get a list of rows in a table representing users or carts or users with stuff in carts. That means you already have a list of fields that are united in rows that are part of a well-defined table with a solid purpose. You can now put all of that in a GUI. Your program can even generate a really solid guess because all the fields also have constraints as to what data format they keep. And then, usually, you can change some things around. So, if you have a URL of an image, you don't just want to put a text box in there, but, for example, an actual image box. On top of that, if you just add a previous and the next buttons, you can now move between records in the entire table. Just go up and down all the users or cards or active cards. Just 2 buttons give you all this functionality. And if you add a little search field, well, you now have a search engine that will only return a list of matching rows or records or users with stuff in their cart. Repeat this 20-minute GUI design process a few times for different tables, and you just built a company management application. Add a few wizards, which is also a common pattern that you see almost every day. This is the next button that you have to click to get to the next part of the form. And now you are capturing complex company procedures that once required a specialist, if not downright an entire department. Now all of that was reduced to a simple wizard GUI. And then add reports, where you sum, average, or map and reduce long columns of fields spanning countless records, and then decorate them with a line or pie chart. On the surface, you see search, previous, next, most of the fields in a pretty form. But beneath, the reason why the UI looks this way is that you are just moving up and down a list of rows, directly over an actual well-defined database table. Or, a virtual table that does some difference or intersection and perhaps picks many different fields from multiple tables that it merges, creating a new table to browse. There are many ways to do database editing, an infinite number of ways, in fact. But you just need this one. It is simple, lovely. The GUI sits right on top of the table or query result. And you got it all. An easy way to edit, search, navigate, make reports, and automate company processes by means of a wizard that now goes out to edit multiple tables, but only one rational step at a time. You already know the patterns. Learning what is under the hood is fantastically easy, motivational, and educational. You don't need to know much. You just need to put your detective hat on and kind of examine the whole program, how it works, how it flows. And then it will hit you. Oh, that is so simple. Yes, it is. It must be. Simplicity means low cost, low maintenance, little refactoring, and no chance to disgrace yourself by calling the first version a reference implementation, as if you planned to create a wreck on purpose. Finally, all of that means that the world of responsible software development is really small. It is easy to master. It is friendly, brilliant, and rational. And it is not scary or intimidating at all. At all.